and welcome to this video on graphing systems of inequalities. I'm going to be modeling how to do this with 3 different problems. You should have a sense of how to graph a inequality in the XY plane before getting here. If you do not, you should try to dig up some resources around that in the form of video or asking your teacher. Okay. One of the ways that will differ in this video and the method that I'm going to use to graph these problems is that I'm not going to use a test point. So if you've seen me or your teacher do a test point to graph these solution sets, you will not see that in this video. As always, follow the directions appropriately on whatever test or quiz or assignment you're giving so that you are fulfilling those requirements appropriately. So here we are just going to graph and shade the first inequality, graph and shade the second inequality, and then shade the solution set. Okay? And these are the steps I'll be using for these systems of inequalities. Okay? So also, I want you to notice when I say graph and shade, I'm just going to do a little minor shading in steps 1 and 2, and then I'm going to do a much thicker shading for the final solution set. And again, the solution set is the set of ordered pairs that make both of these statements true. So you should also bring that idea to this as well. So, okay, let's get going. I'm going to graph the first example in red, and I'll graph the second problem of the example, I should say, in blue. So what we'll do is we'll graph and shade this first statement. I'll make a quick B and M chart, excuse me. Instead, I'm going to do that in red. So B equals 3, and M equals 1/2. So I will start at 3 on the y-intercept, and I'll go up 1 and right 2. I'll do that repetitively so I can see the line a little bit. And then I also note here that this is going to be greater than, so it's going to require a dotted line because it's not greater than or equal to. Okay, so I will get the dotted line tool out and graph that. And I won't do a test point because you should have done enough test points to understand that if the inequality says greater than, well, it probably sounds like it's above the line. So I'm going to do a little mini shading here above the line. And again, what does it mean? It means that all of the ordered pairs that are above this line are true for this statement. Okay, now moving on to the second statement in this linear system of inequalities, I will make a B and M chart here, B the y-intercept being -1 and M being -2, which is -2/1. And I could add this extra information here, the denominator, because it's not the final answer. It's just going to help me read my answer better. Okay, so, or excuse me, read the information in the problem better. So now I'm going to go put a dot on -1 on the y-intercept. Come down to right 1, come down to right 1. I'll repeat that so it's easy to see the line. And I notice here that this is a less than or equal to, which means points on the line are part of the solution. So I'm going to use a solid line. Okay? And if it says less than or equal to without doing a test point, it should be reasonably comfortable to say we're going to shade under the line. So I'm shading below the line again with some mini shading. Sometimes I refer to them as just little nubs. Okay? So now we're in step 3, which is the solution set, which I'll do that in purple for the particular reason that red and blue blended together will make purple. So the solution set is where we have points that are true for both statements. And I'll try to do this slowly so you can read it. Well, I'm looking for this region. If you notice the graph, both graphs of the line split the XY plane into 4 areas here, which I'll call A, B, C, and D. Okay, you might even see the answer already. Okay, so if you notice here in what I called C, there's nothing true for red and nothing true for blue. Okay, and then over here in B, there's nothing true for blue, but there's points that are true for red. Okay, and what I called D here a moment ago, we have things that are true, ordered pairs that are true for blue, but not the red. And in this area called A, you notice we have points that are true for red and true for blue. So the final solution set is going to be this region here, the infinite set of points bounded by those two lines, okay, where we say every ordered pair in there is going to be true for both statements. Okay, I'll move to the next example. I'll follow the same steps, and I'll try and give you some variety here. I'll do the first example in red, first problem of the example in red, second one in blue. Okay, so it says graph and shade the first inequality. Now, if you notice, this inequality is just one variable. Okay, so you need to be able to understand how to graph that. So if I were graphing just x equals 4, okay, it would make sense to go put a line through the x-axis at 4, and it would be a vertical line. So I will put a point on 4 and put a vertical line through it. Again, this is an example where the line will be dotted because it's just less than 4, not less than or equal to. And less than, given the choice between left and right, I would hope you would say by now it would be to the left. Okay? Now, the example in blue here, we're going to see it's kind of a form of ymx plus b. So I'll make a bm chart. B is -1 for the y-intercept. Slope is 2/3, which means go up 3 and right. Excuse me, up 2 and right 3. So starting at -1 with a dot, I'm going to go up 2 and right 3 and repeat that process a couple of times to see the line a little bit better. Come back to the y-intercept, go down 2 and left 3, down 2 and left 3. And we also notice that this is an or equal to problem, so we can use a solid line there. Okay. Okay. Now, it says to graph less than or equal to, so that'll be below the line. So I'll put some mini nubs of mini graph here, below the line, and now we're looking where these areas intersect. Well, here there's true for red but not for blue. Here's true for neither, not true for red, true for blue, and in this area we see it's true for blue and true for red, so the solution set is all the points in here. Okay, so your final answer is all the points in purple, okay, and as well as these ones that are on the blue line up to this point, okay, not including it, as well because that's also or equal to. Points that are on the red line here, I'm sorry, I traced it in blue, they're not true, that's why the line is dotted. Okay, final example here. Same steps, graph and shade the first inequality, graph and shade the second inequality, and then shade the solution set where we in fact have overlap. If you notice again in this example, which I'll do the first part of the statement in red, it's a single variable statement. So if I were graphing y equals -2, I would be going to y, putting a dot on -2, and then using a line that's horizontal. Probably noticed that it's going to be dotted because this is strictly greater than. Okay, and greater than would make sense to shade above this line. Although I'm just shading a little bit above the line, don't forget everything up here is true for that red statement. I'm just not putting in big thick lines for the sake of junking up my drawing. Okay, now you notice in the blue one here we don't have y mx plus b form, so I will do that. Now I'll isolate y, so I'm going to subtract 6x from both sides, which will give me -3y is greater than -6x minus 9. Again, this order doesn't matter as long as I keep the signs consistent with the terms. And now I'm going to divide by -3, and something should go off in your head, a red flag, okay, that you're dividing by a negative, so you're going to have to flip this symbol. So that will give me y is less than 2x plus 3. And then from there I can make a b and m chart where the y-intercept is 3, the slope is 2 over 1. So I'll be able to write my arrows in to help me if I need them. Okay, so I'm going to start on the y-intercept at 3, go up 2 and right 1, up 2 and right 1, run out of space, so I'll come back. Again, the skill of making a line is something you should have learned a while ago, so that shouldn't be too hard for you to follow. We also see that this symbol here is strictly less than, which means points on the line are not true for the statement, which means I will do a dotted line here as well. And where now that we have to look at this symbol, not the original one, okay, because we've graphed this statement. Okay, it says to shade below the line, so I will do so. These little nubs, sort of mini graph again. You notice here in step 3 where it says shade the solution set, you're seeing in this area here is where the truths intersect. Therefore, this area contains the solution set, and again, the solution set is all of the ordered pairs that make the statement true. So I hope this was informative and showed a variety of examples. If you're able to graph a line in a variety of forms, whether it's single variable or two variable, and two variables even where you have to get slope-intercept form, you should be all set, okay? The shading, again, just to review, if you have less than, it would be shade under, and the line is dotted. If you have greater than, it would be shade above, and the line you're using would be dotted, okay? And then if you have less than or equal to, or greater than or equal to, both of those lines would be solid, but the less than would be to shade under or below, and the greater than would be to shade above the line. The only time that is not useful is if there is no above or below the line, which would happen in a vertical line situation, where you would be shading either to the right or to the left, okay? Right would be a greater, so I'll put in a little note here. It just says greater is either above or to the right, okay? And under for less than would be similar to shading to the left if it were just a vertical line. So this part here is just a little tricky because there's no above or below in a vertical line. But feel free to practice. I hope this is a help, and enjoy.